Welcome. Today, I think I'm going to take a look at trying to do some gravity because I want a simple gravity system, but I haven't really been able to find one. So here's how I did it, or at least I attempted it. So I created a blank first-person project, created a test map as you can see here, with a couple player starts around a basic sphere around 0, 0, be our gravity location. I moved all the stuff to the assets, this assets folder. I created a components folder with a gravity system subfolder. Created a game folder with a game mode pawn and a player controller. Player controller was set up with the input system with the pawn here was set up like a normal character, except for there's no movement here because it's just a basic pawn. Um, we'll start off here actually. We were gonna start in the pawn actually because we just want to set up the basics here. And so the first one is going to be, we're going to add a movement. We're going to actually add our floating pawn movement. So with this movement system will deal with vectors instead of dealing with simulating physics. Although you can simulate the physics. But let's go ahead and toss down our input actions. So we've got the move and we got the look. And from the look here, let's go ahead and we're just going to add a actor local rotation. And let's go ahead and split this. And this is going to be our yaw. It's our yaw. It's our Z value. I keep forgetting. Still have no clue what yaw pitch and roll stands for. Anyways, grab our spring arm here and we will add a relative rotation and we'll split this. And this is going to go into a pitch. I know what pitch is. Pitch is up and down. Roll and yaw still confuse me. Oh well. It is what it is. Go down to the move now and we're going to make a small function here that just says do move. And this is the function that we're gonna use to control how much movement input gets passed in. So I will pass in it in a direction and a delta, which will be a vector and a float. So we've got direction, which is a vector, and delta, which is a float, and we will multiply these two together. And then we will take our floating pawn movement and we will simply add input vector and pass that vector in to our movement component. We'll add it as a force and compile and save. Now over in the event graph, let's go ahead and pull this out twice. Now for our first one, for the direction, we're going to want to get actor right vector. And our delta will be our x. And we'll pass that right in. Now for our delta y, for our delta for a second value, we're going to pass that to y. And for our direction, we will simply get the forward vector. And set them as little hats. Now that sets up the pawn movement here. You can see that here. You look up and down, left, right, forwards, backwards. There's no gravity. We are simply floating. Fantastic. Let's go ahead and work on the gravity system now. So I have the custom folder I created here for this, and we're going to start off by creating. We will start by creating a, where is it here? Miscellaneous data table. And for this, we're going to be using a gameplay tag table row. GT gravity tags. Go ahead and open that up. Let's go ahead and add a new one here. Row name for gravity enabled. And our tag we will set as gravity dot enabled. Fantastic. Now let's go ahead and apply this table in our settings, in our project settings. So in our project settings, let's go to the gameplay tags, apply, or it's, yeah, here you go. For some reason it kept when I did this, when I tried to test it before. But anyways, we go into the tag table list here, simply add it. Now we have our gravity dot enabled. Great, we can save and close that. Now, the next one we will want to set up is we'll go into the blueprints and we'll set up a blueprint function library. We can call this BFL gravity utils, I guess. And in here we are going to have simply one function that does, let's see, BFL. We'll do it as apply gravity on. Now from here, we'll add 3 inputs and 1 output. And from this, we want to do the gravity location, which will be a vector. A gravity strength will be a float, which will be a float. And then from here, we want to get the third variable here is going to be an actor object, and this is going to be the actor to calc from. And then as the output, we want the new transform here. Simple enough. Go ahead and split that. Now, from the actor input, let's grab the forward vector and the current transform, or the get actor transform. We'll go ahead and split that. You can go ahead and connect up the scale because we don't need that. Now let's go ahead and set up a few nodes here that we're going to need for our calculation. And one of those is we're going to need to do a get unit vector. We will want to get another node, find look at rotation. And these tos and from starts to targets, I will explain those in a moment, but those will be our various calculations here. But let's go ahead and fill out the second half of this first. So from this unit vector, this is going to be technically the vector from our location to the gravity, which we will then multiply this by our gravity strength. So this is going to be our gravity vector that we return. And so this goes to our location from our gravity location. Or no. I got that backwards. Remove this pin. I got this backwards. We want to go from our location to the gravity location. They get kind of confusing, but because we want to go from the look at rotation now, we want to go from the start, from the gravity location to our current location. Or the start is the gravity location and the target is the actor location. Yes? Now from this look at rotation, we need to do a bit more calculations. So we want to get the forward vector off of this. So whatever the rotation between our start and target is, whatever that forward vector would be. And off of this forward vector, we want to make rotate from z to x. So this forward vector is our up vector, and this x vector is our forward vector. Make sense? And then we plug that into the rotation. So what we're doing from here is we're going from a gravity location or from our, we're going from our current location to the gravity location, that vector, and then we're multiplying it by a strength. It's a unit vector, so it's very tiny. So we multiply that by the strength, and that sets us back our new transform location. Then this goes into the rotation, which takes from the gravity location to our current location, gets that forward vector. So this is going to get the up vector effectively from the surface. And then we want to change the x from the z. So whatever the z is, we want to change the x to make sure that z is always pointing upwards. So this will apply this is going to apply a forward rotation. Or a looking forward rotation, I guess. I don't know, something along those lines. So moving on here, so that'll be our function library. Let's go ahead and create a simple blueprint interface here. BPI gravity actor. And this interface is going to have two things, and it's going to have as gravity actor. And this is going to output us the current interface actor reference. Which will always be basically self. And then we want an actor, which is going to be the actual object, because the interfaces aren't treated as objects, but we need objects. So we're just going to pass it back as the actor, because this interface should always be basically on an actor, but if you're not using it, and I don't know what you'd do. It just makes our life a little bit easier. Anyways, the next function is going to be a apply movement. And this is going to be our input of our new transform. This is whatever we want to change the actor by. Because the component will just effectively just do a calculation and then pass that back to us. So let's go ahead and create that component now. There we go, BP gravity component. There we go, and this thing will only be doing one thing. So on every tick, we're going to do a certain function. That's going to be update gravity, or update something else. I don't know. But this will do a couple of things, and we're going to need a couple of variables to go along with it. So we'll add 3 variables here. One, and they are all, except for the last one, going to match what we had. So for the first one, this is going to be the gravity location, and then the gravity strength. We're controlling the inputs through this component. So that way we can modify things for this in this component. We've got the function we can modify things in. So we can do things at different levels. And this last one is going to be a gravity tag container. And this is going to be a gameplay tag container. So like the gameplay tag that we created earlier, we can simply add and remove it from this container and toggle gravity on and off. Simple enough. Enable the eyeball so we can get access to it. So we can simply say has tag exact match, and we are looking for gravity enabled. We can go ahead and just branch off of this, pass it in, and then from the true pin, we'll want to get owner, and then as gravity actor, message it off this true. Now we have access to the actor reference and the gravity actor. Let's go ahead and just do the BFL apply gravity on, and from our gravity location, we'll send it to the gravity location. From the gravity strength, we'll send it to gravity strength. And the actor, we have the actor here, so let's go ahead and pass that in. Okay, and then off this interface reference here, we can apply movement, and off this new movement, we get the new transform. We can simply pass that through. Simple stuff. Okay, pass that through. Do all that. Do all that. Go. So we check for a tag. If it's true, we apply. We check the owner. If it's a gravity owner, we can simply apply the gravity to it, pass it back to the new, and then we can simply say, hey, Mr. Gravity Actor, apply your movement. This is what the gravity is. So let's go ahead and over into the pawn and go ahead and add our gravity component. Now for this gravity component, we can go over to their settings here. And in the gravity location, we'll be pointing towards 0, 0, 0. For a gravity strength, let's go ahead and just put that as 1. And let's go ahead and add the gameplay tag of gravity enabled. Now for our pawn, our gravity will be enabled. Let's go ahead and open up the class settings and add our interface now. BPI Gravity Actor. Let's go ahead over into the interfaces. We can do as Gravity Actor. We can simply set this to a reference to self for both of these, since it is both a gravity actor and an actor. We can go ahead and apply this movement. And now off this new transform, we can split this pin. We have the gravity that we transform, and then the gravity transform, and then the pin. We can go ahead and do our move of the function that we did in the direction of the gravity. I don't remember. Was delta supposed to be positive 1? I think 1. But anyways, this gives us another way of controlling the movement. So if we want to go up, is it up is 1, down is -1. But this gives us another layer to transform it. And then so we can set actor rotation off of this rotation. And just, I had so used to splitting the structure pins. But yeah, so I think that this should be either a 1 or a -1. I don't know. We'll play and find out. Or we'll play and it won't work. So what did I do wrong? We applied the tag. We are applying the gravity on. In our component, we're doing a tick on this. Oh, we're not calling it every tick. Here we go. Let's update gravity every tick. Okay, now we got some weird behavior. Okay, so that weird behavior is set up because I forgot to check the capsule collision. And we want to actually make this a different collision. And this is going to be a block all or block all dynamic. That's your choice. We effectively just fell through the world right there. It pulled us towards 0, 0, and we got stuck at 0, 0. Now we have collision, and now we can walk around a sphere. Pretty good stuff. And we've moved whichever way we're facing. So now we can play the classic Sonic game. Let's go. Just add some orbs, and we'll be collecting some orbs on a sphere or something, and set the rotation to 90 degrees. All right, yeah. See, we can just walk. Be terrified by the ocean because we're upside down. Fantastic. Let's go ahead and add this to. Let's go ahead and simply create a static mesh actor here. And this is going to show us how to do it to an item now. So I'm going to do BPSK gravity item. Let's go ahead and open this up. Let's, for our static mesh, let's go ahead and make this a cube. Let's go ahead and add a box collision. Go ahead and set the box extent to a 50, 50, and 50. I'm pretty sure that was what it was, what it should be for the cube. Let's go ahead and add the gravity component. Let's go ahead and pull it at a strength of, let's say, 100. Let's go ahead and add the tag for enabled towards the location of 0, 0. Now for this, we want to add how we're moving this item, and this time we are actually not going to be simulating physics. So we're going to actually use a projectile movement to control it. Let's double check the collisions here for a second though, just to make sure. We got boxes overlap all. Is this block all? Collision presets are default. Let's just say block all for the static mesh, or block all dynamic for the static mesh. Now over in the class settings, we can set up our interface. Set up the gravity actor interface. Go over to the interface here. Set this up itself. Compile first because it doesn't know. There we are. Plug that into both of those pins. Go ahead and apply this movement. And so in this movement, we can then take our projectile movement. And this is what I meant why we have simply return this transform, because we can now control this movement by different methods. So we're controlling this by the projectile movement. We're controlling the other way by our other movement. So we'll stay off this projectile movement. Let's go ahead and just set the velocity to our gravity vector. And then we'll also go ahead and we'll set actor rotation. We'll go ahead and set the rotation just like we did before. Just like that. Okay. Oh, these are static mesh actors, right? If you're working with regular actors, sometimes they are movable. Sometimes the static mesh actors, they tend to be the ones that are not movable. So do that. Go ahead and just pull a bunch of these out into the world. I should have put them in a better place. For sure. Yeah, I should have just put them in a better spot. Anyways. See. I just need a bunch of them. That's all I need. Okay, now if I hit play, do they all... Yeah, they're falling. Whee! They're coming towards the planet. Let's update. Let's increase the strength here of this gravity component. Go ahead and update this to like 500 maybe. Yeah, well, I've been in my testing, I've been using 500, but yeah. There you go. Let's pop it to F8 and watch this. It's like a magnet. It's kind of addicting to watch. Obviously now all the boxes are on the one side, but you can see that they come towards this location from wherever they are. They face and then they come towards the direction. So yeah, it's just like one giant magnet. And I believe it's F8 to go back into character. Yep. We can go around the sphere. Man, if these boxes were breakable, we'd have actually like some sort of gameplay here. Just run around on a sphere and destroying boxes. Movement here is a little jittery, but that's okay. You can if you apply the transform over an interpolation speed, you can get some pretty smooth movements. But yeah. Well, with projectile movement too, it's a little weird because the boxes stop simulating as soon as they get a collision event. You can work around those, or you can update it. You could use physics movement if you wanted to. Yeah, there you go. Cool. I'm out.